Hi everyone, this is Ms. Shea. In this video, we are going to go over how to do dilution calculations. Now before we get started, I would suggest that you print this handout or get your own sheet of paper so you can follow along with me. You also need a calculator. So let's get started. First of all, let's figure out what dilution means. When we dilute a solution, we are adding more solvent to the solution. Doing this will decrease the concentration while increasing the volume. Basically, what we are doing is watering down the solution. Dilution calculations are often very important in chemistry because we often have stock solutions that are very concentrated. Stock solutions are simply the chemicals that we get from the companies that sell them. And when they come to us from those companies, they're usually very concentrated and not at a concentration that we want to use. And so we need to be able to dilute it. Now, in order to do these dilution concentrations, we're going to be using this equation. M1V1 equals M2V2. M stands for molarity, which is our usual concentration unit, and V is volume. M1 is the molarity of the solution before diluting. V1 is the volume of the solution that we will take so that we can dilute. M2 is the molarity of the solution after diluting, and V2 is the final volume of the solution after diluting. Let's do a couple examples. The first example says you have 53 milliliters of a 1.5 molar solution of NaCl. To how many milliliters do you need to dilute it to get a 0.8 molar solution? Let's look at our givens. We know that the original solution had a concentration of 1.5 molar, so that is M1. We also know that we have 53 milliliters of it, that is V1. We know that we are going to dilute it to 0.8 molar, that is M2. And we're looking for milliliters of the solution after the dilution, so we are looking for V2. The formula is M1V1 equals M2V2. So let's plug in the numbers. M1 is 1.5 molar and V1 is 53 milliliters. M2 is 0.8 molar and V2 is our unknown. To solve for V2, all we need to do is divide by 0.8 molar on both sides. This will allow 0.8 molar to cancel out on the right side and leave V2 by itself. And in our calculator, we're going to type in 1.5 times 53 divided by 0.8. And the answer is 99.375, and we are going to round that to the whole number, 99 milliliters, because V1 is rounded to the whole number. The next example says 50.0 milliliters of a solution are diluted to a volume of 100.0 milliliters. The concentration of the diluted solution is 2.0 molar. What was the concentration of the original solution? Again, let's look at what we are given. We know that the original solution had a volume of 50.0 milliliters, and we diluted it to 100.0 milliliters. There's V1 and V2. We also know that the concentration of the diluted solution is 2.0 molar. That's M2. We are looking for the concentration of the original solution. So we are looking for M1. Again, the equation is M1V1 equals M2V2. M1 is the unknown. V1 is 50.0 milliliters. M2 is 2.0 molar. And V2 is 100.0 milliliters. To get M1 to be by itself, we're going to divide by 50.0 milliliters on both sides. And M1 is then by itself. And in our calculator, we're going to type in 2.0 times 100.0 divided by 50.0. And the calculator says 4. Now I'm going to go ahead and write 4.0 molar because M2 is 2.0 molar. So I'm going to keep the same number of decimal places. Let's do one more. I'll do practice problem number 1. You need 225 milliliters of 0.60 molar NaOH solution, and you have a 2.5 molar stock solution. What volume of the stock solution do you need for this dilution? Again, let's look at our givens. 225 milliliters of 0.60 molar is what is needed. So that means that will be after the dilution. So that will be V2 and M2. It says you have a 2.5 molar stock solution. Remember that stock means that it is from the cabinets. So that is M1. And it's asking you for the volume of the stock solution. And that means we're looking for V1. Again, our formula is M1V1 equals M2V2. M1 is 2.5 molar. V1 is the unknown. M2 is 0.60 molar, and V2 is 225 milliliters. Once we have plugged those in, we need to solve for V1. And to do that, we're going to divide by 2.5 molar on both sides. V1 is then isolated. In the calculator, we're going to type in 0.60 times 225 divided by 2.5. And the answer is 54 milliliters. Since V2 is rounded to the whole number, then I'm going to leave V1 as a whole number as well. I want you to pause this video and do number 2 and 3 by yourself. When you are done, come back and check your answers. All right, in number 2, we are given M1, V1, and M2, and we are looking for V2. When we plug all of the numbers into the equation, what we get is V2 is equal to 500.0 milliliters. In number 3, we are given M1, V1, and V2. We are looking for M2. Once we plug all the numbers into the equation, we get 2.0 molar for M2. So how did you do? Let's look at a few more examples. In particular, we are looking at the dilution of acids and bases. Acids and bases are usually purchased in concentrated form. However, we rarely want to use the acid or base in its concentrated form because they're very dangerous in that form. We must dilute it to the exact concentration we want to use. In this table, we have the concentration of different acids and bases in their concentrated form. And we're going to use this chart to do the next few problems. Let's do a couple examples from this page. I'll do number 1 and number 3. Number 1 says, what volume in liters of concentrated hydrochloric acid is needed to make 3.0 liters of 1.0 molar HCl? Let's look at what we are given. 3.0 liters of 1.0 molar HCl are what we are wanting to make. So 3.0 liters is V2 and 1.0 molar is M2. It's asking us for the volume in liters of the concentrated hydrochloric acid. So we are looking for V1. But where is M1? Well, that is in the chart. Hydrochloric acid has a concentration of 12.1 molar when it's concentrated. So we're going to use 12.1 molar as the M1. All right, so let's plug it into the equation. M1 V1 equals M2 V2. M1 is 12.1 molar, and V1 is the unknown. M2 is 1.0 molar, and V2 is 3.0 liters. We need to isolate V1, so we're going to divide by 12.1 molar on both sides. And V1 is equal to 1.0 times 3.0 divided by 12.1. And the answer is 0.2479. Now I'm going to round it to just one decimal place because that is what V1 had. So 0.2 liters. And that is our answer for number 1. Let's skip down to number 3. Number 3 says, to perform an experiment, you need 0.300 liters of 6.0 molar nitric acid. You go to the acid cabinet and discover that you have 100.0 milliliters of the concentrated acid. Do you have enough acid to complete the experiment? And they gave us a hint. Calculate the volume of the concentrated solution that is needed, then compare to the 100.0 milliliters that you have. All right, so I'm going to take the hint, and let's calculate the volume of the concentrated solution. That means we're going to calculate V1. Remember that concentrated just means before diluting. The problem says that we need 0.300 liters of 6.0 molar nitric acid. So there is our V2 and our M2. Now since it tells us that we are looking at nitric acid, I'm going to go back to the chart to find nitric acid. And we see that nitric acid in its concentrated form has a molarity of 15.9 molar, and that is M1. So let's plug this into the formula. M1 V1 equals M2 V2. M1, we just figured out from the chart, is 15.9 molar. We are looking for V1. M2 is 6.0 molar, and V2 is 0.300 liters. We're going to isolate V1 by dividing by 15.9 molar on both sides. In the calculator, we're going to type in 6.0 times 0.300 divided by 15.9. And the answer is 0.0 0.113 liters. Now this is not the actual final answer that we want because the question that they were asking us about was, do you have enough acid to complete the experiment? Well, how much acid was in the cabinet? We had 100 milliliters of the acid. Well, 100 milliliters, to convert that into liters so that we can have a fair comparison, we just need to divide by 1,000. And that is 0.1000 liters. So we need 0.113 liters of the concentrated solution, but in the cabinet we only have 0.1000 liters. So what this means is, no, we do not have enough acid to complete the experiments. Now I want you to pause the video and do number 2 and number 4. Once you are finished, come back and check your answers. So for number 2, we know that we want to make 250 milliliters of 0.5 molar NH4OH. So 250 is V2 and 0.5 is M2. We are looking for the volume of the concentrated ammonium hydroxide. So we are looking for V1 and M1 is in the chart. We're looking at ammonium hydroxide, so M1 is 14.5. Once we plug in all of the numbers into the formula and solve for V1, we get 9 milliliters. Now I rounded it to 9 because V2 says 250 milliliters, and that is a whole number. So I went ahead and rounded V1 also to a whole number. Now let's look at number 4. In number 4, it says that we have 3.0 liters of an unknown concentrated acid, and that is mixed with water. So 3.0 liters is V1. And in the end, after mixing with water, we get 22.2 liters and 2.0 molar. So V2 is 22.2 and the 2.0 is M2. And it's asking us, what type of acid is it? So obviously we're not really looking for M1, but M1 is going to help us figure out what type of acid it is, because M1 is the original concentration of this mysterious acid. So when we plug in our numbers and solve for M1, we get 14.8 molar. If we go back to the chart, the acid that has 14.8 molar for its concentration is phosphoric acid, H3PO4. So the type of acid this is H3PO4.